Welcome to the industrial boiler types under the edges of chemical process utilities. Now, before we go into the detail of this particular aspect, let us have a look at what we had discussed in the previous lecture. Previously, we discussed about the basic qualification of boilers. We discussed about the different type of boiler classification, fire tube boiler, water tube boiler, etc. So, different type of a boiler. It may be based on the pressure, it may be based on the fuel, it may be based on the other aspects in question. We have discussed about the tubing system of boilers. We had discussed about the merit and demerit of the water in tube type boilers. In this particular lecture, we are going to discuss about the concept of Stoker Fired Boilers. We will discuss about the pulverized fuel boiler. Pulverization is a very common phenomenon in chemical engineering. We will discuss about it. Then we will discuss about the fluidized bed combustion boilers, again to maximize the efficiency of the boiler. These are the different type of boilers. We will discuss about the concept of high pressure boiler. Now see, when we talk about the boiler, so obviously the first question usually comes in our mind is that whether this particular boiler meets our requirement pertaining to the energy, pertaining to the steam, pertaining to the other aspect in which they are designed. Second aspect is usually comes in our mind is that what is the efficiency of the boiler with respect to the energy, because everywhere you require the fuel, and obviously we will require the proper efficiency of the boiler, maximization of the fuel economics. And the third aspect usually comes in our mind is that is attributed to the environment aspect. What is the composition of the flue gases, how much flue gases are there, and obviously this all depends on the choice of fuel as well as the boiler design and the boiler used in question. So based on this particular aspect, different type of boilers and different type of inner configuration of the boiler or anatomy of the boiler has been devised. Now, Stoker Fired Boiler is again one of that particular anatomy of the boiler. So, usually these stokers are classified according to the method of the feeding of the fuel to the furnace and by the type of the grate. Now, usually we are having the different choices of fuel. One of the best choice of the fuel is coal, and how we are feeding this particular coal or fuel to the boiler, that is the based on this Stoker type of thing. So, basically when we talk about these Stoker fired boiler, there are two type of a classification. One is that chain grate or travelling grate stoker, and second one is the spreader stoker. So, let us have a discussion about the chain grate stoker type of a boiler. Now, here you see that as per this particular diagram, we are feeding the coal at one end, and there is a there is a steel chain grate. Here you see that steel chain grate. Now, as grates move along the length of the furnace, the coal burns before dropping off at the end as a ash. Now, see, it is a simple combustion process. For combustion, what you require, that is a source of carbon that supplies by the coal. Second is the adequate supply of oxygen, and obviously in the boiler system we are using the air as a source of supply. So, this particular combustion process releases the energy, and if it is the complete combustion or a partial combustion, some sort of ash. Now, here if you see that there are certain air seals, air compartments, etc., all these things are mentioned over here to maximize the combustion process, because ultimately we had already talked about the energy efficiency aspect. So, if there is an incomplete combustion, obviously your boiler efficiency will be on the lower side. Now, here you see that some degree of skill is required, particularly when we are setting up the grate, air dampers and baffle, because usually baffles are used to ensure the clean combustion, leaving minimum of unburnt carbon in the ash. Otherwise, it may pose the environmental problem as well as it may create the non-economical operation aspect of that particular boiler. Now, the coal feed hopper usually, this is the coal feed hopper, runs along the entire coal feed end, you see over here, to the end of the furnace. Now, a coal grate is used to control the rate at which the coal is fed into the furnace. So, if the rate is on the higher side, definitely you may experience that there are certain amount of coal being unburned. Now, to control the thickness of the coal bed and speed of the grate, again this particular grate is being used, because if the size of the bed is on the higher side, there may be a chances to formation of the stagnant zone, and these stagnant zone may create the concept of unburned coal. Apart from this, another requirement is that this coal must be uniform in size. The large lump may create the problem of unburnt carbon, and sometimes it may be very difficult to burn them completely till they reach the end of the grate. So, these are the complexities. Now, as you see that the bed thickness decreases from coal feed end to rear end, the different amount of air are required. More quantity of the coal feed end at the less at the rear end. See, when we talk about the combustion process, it obviously that we are feeding air. Now, air again sometimes sometimes it costs. So, that is why the optimized supply of air is again quite essential, and that is why whenever there is a depletion in the amount of a coal, then you can alter the supply of air to the boiler system. Now, let us talk about the spreader Stoker boiler. Now, the spreader Stoker utilize the combination of suspension burning and grate burning. Now, usually suspension burning offers higher surface area, and in that case the combustion efficiency is on the higher side. So, usually the coal is continually fed into the furnace above the burning bed, you can see over here, and the coal fines or the fine particle coal, they are burnt in suspension. So, the larger particle fall to the grate over here when they burnt in a thin and fast burning coal bed. Now, this method of firing provides a good flexibility to meet load fluctuation. Now, since you see that ignition is almost instantaneous when firing rate is increased. Therefore, the spreader stoker is favored over other type of stoker in many industrial applications. Now, let us talk about the pulverized fuel boiler. Now, most coal fired power station boilers, they use the pulverized coal, and many of the larger industrial water tube boilers are also use these pulverized fuel. Nowadays, this particular technology is well established or well developed, and there are thousands of units around the world accounting for well over, you can say, 90% of coal fired capacity. So, usually what is the concept? The concept is that the coal is ground or pulverized to a very fine powder, so that less than 2% is plus 300 micrometer, and almost 70 to 75% is below 75 microns for bituminous coal. Now, it should be noted that a too fine powder is again wasteful in grinding mill power. Now, usually you need to incorporate more and more power to make them fine powder, and sometimes it may become charred over the period of time. Now, on the other hand, if you are having too coarse powder, it does not burn completely in the combustion chamber and results in higher unburned losses. So, the pulverized coal is blown with part of combustion air into the boiler plant through a series of burner nozzles. Now, sometimes you may need to incorporate the secondary and the tertiary air. Now, this air may be added in the combustion process. Now, combustion usually takes place at a temperature from say 1300 to 1700 degrees Celsius, depending upon the quality of the coal, or you can say the grading of the coal. You may see that the particle residence time in the boiler is typically 2 to 5 seconds. Again, it is an art to maintain this residence time so that the combustion efficiency may be enhanced. So, the particle must be smaller enough for complete combustion to have taken place during that particular time. The pulverized coal firing system was covered in the previous lecture, as you noticed on the furnace, where we had studied about the unit direct bin central type of a system. Now, this system has many advantages like ability for fire varying quality of the coal, quick responses to changes in load. You may use the high preheat air, temperature, etc. One of the most popular system of firing pulverized coal is the tangential firing using 4 burner corner to corner to create a firewall at the center of the furnace, so that you may experience the enhanced temperature. And now, let us talk about the fluidized bed combustion boiler. Now, when an evenly distributed air or gas is passed upward through a finely divided bed of solid particles such as sand supported on fine mesh, the particles are undisturbed at a low velocity. Now, as you increase the air velocity gradually, a stage reached when individual particles are suspended in air stream, so that the uniform distribution of air may take place. Now, if you further increase in velocity, this gives rise to bubble formation, vigorous turbulence and a rapid mixing, and the bed is said to be fluidized. This is the usual phenomena of fluidization. Now, if the sand in a fluidized state is heated to ignition temperature of the coal and coal is injected continuously into the bed, the coal will burn rapidly and the bed attains a uniform temperature due to effective mixing. Now, in this particular case, the proper air distribution is extremely important. This is to maintain the uniform fluidization across the bed. Now, ash is disposed by dry and wet ash disposal system. Fluidized bed combustion has significant advantages over conventional firing system and usually offer multiple benefits like fuel flexibility, reduced emission of noxious pollutants such as SOx, NOx, compact boiler design and higher combustion efficiency. Now, let us talk about high pressure boilers. High pressure boilers again are very useful in various industrial operations, and especially you may require sometimes variation in the pressure, maybe as per the choice of your process, then these are the very good candidates. So, in all modern power plants, high pressure boilers usually greater than 100 bar, they are universally used as they offer the different advantages. One of the advantages is that the efficiency and the capacity of the plant, it can be increased, it can be reduced as the quantity of, as per the choice, as per the quantity of the steam required for the system. So, if you require the same power generation, if high pressure steam is used, then you can enhance or reduce the different parameters as per the requirement. Now, the forced circulation of water through boiler tubes provide freedom in the arrangement of furnace and water walls. Now, in addition to the reduction in the heat exchange area. Now, the tendency of scale formation is reduced due to high velocity of water. We are using the high velocity, so the deposition rate is substantially on the lower side. The danger of overheating is also reduced as the parts are uniformly heated. So, overheating, bending of tubes, shell, etc., these kind of things can be avoided. The differential expansion is reduced due to uniform temperature, and this reduces the possibility of gas and air leakage. Now, let us talk about the Lamont boiler in this category. Now, this is the typical figure of Lamont boiler. The couple of things are very common in every boiler, that there must be a route for exhaust gases, like here we are having. There must be a combustion chamber, like here we are having. There must be some steam releasing system or steam separators. You must have some water feed pump, etc. There may be some, if you are recirculating the things or steam, you are superheating the steams, then there must be a sludge removal device. Obviously, to maximize the efficiency, you must have an economizer in place and a superheater, obviously. So, all these things are there in every type of a boiler. So, usually in the Lamont boiler, a forced circulation boiler, usually it is termed as a forced circulation boiler, and it was introduced in 1925 by Lamont. The arrangement of water circulation and the different components we have already enlisted. You can see here there is a radiant evaporator, and you see that the water is passing through. So, by this way it is being preheated as well as it is giving you the superheated steam. Now, usually if you see that the feed water from hot well, this is the hot well, is supplied to storage and separating drum, that is the boiler, through the economizer. Here you see, and after the economizer the things goes to the atmosphere or the air treatment plant. Now, most of the sensible heat is supplied to the feed water passing through the economizer. Usually a pump circulates the water at a rate of say 8 to 10 times of mass of steam evaporator. That is the theoretical calculation. Now, this water is circulated through the evaporator tubes. Here you see that these are the evaporator tubes, and the part of vapor is separated in separation drum. Now, the large quantity of water circulated, almost 10 times that of evaporation, it prevents the tube from being overheated. So, this is a plus point because the bending of tubes or deformation of the tubes can be easily avoided. Now, usually the centrifugal pump, they delivers the water to the header at a pressure of 2.5 bar above the drum pressure, and that is again a very plus point. So, the distribution header, they distribute the water through the nozzle into the evaporator. So, the steam separated in the boiler is further passed through the superheater. Here you see that this is the superheater. Now, secure a uniform flow of feed water through each of the parallel boiler circuits. A choke steam power plant is fitted at the entrance of each circuit. Now, these boilers have been built to generate 45 to 50 tons of superheated steam at a pressure of say 120 bars, and the temperature usually is around 500 degree Celsius for different type of industrial uses. Now, let us talk about the Benson boiler. So, now Benson boiler is evolved somewhat later than the Lamont boiler, because the main difficulty experienced in the Lamont boiler is the formation and attachment of bubbles on the inner surface of the heating tube. So, this may cause the corrosion, this may cause some foam formation. So, that is why the Benson boiler it was evolved. Now, the attached bubbles they reduces the heat flow in steam generation as they offer the high thermal resistance compared to a water film. So, if the boiler pressure is supposed to raise to a critical pressure and that is 225 atmosphere, the steam and water usually have the same density. Therefore, the danger of bubble formation you can easily or you can completely avoid in Benson type of boiler. So, it was a very small phenomena through which you can utilize and you can maximize the things. So, you see that from Lamont boiler to the Benson boiler, the system is evolved over the period of time. Now, usually the natural circulation boilers they require the expansion joints, but these are not required in the Benson boiler. Now, the thing is that if you are having the expansion joints, in that case the chances of wear and tear may be more prominent. So, the erection of Benson boiler is usually easier, it is much quicker than the previous one. Now, because the reason is that all the parts are welded at site and the workshop job of tube expansion is altogether avoided. So, these two added benefit they offer and they poses a good candidacy of Benson boiler over Lamont boiler. The transportation again a very crucial aspect in the boiler system. The transportation of Benson boiler part is easy because no drums are required and the majority of the parts they are carried to the site without pre-assembly. Now, these Benson boiler these can be erected in a comparatively small floor area. The space problem does not control the size of Benson boiler, whatever Benson boiler you are using, it does not pose any kind of a restriction. The furnace walls of the boiler, it can be more efficiently protected by using small diameter and close pitch tubes. So, you can say the protection of this boiler with respect to the safety is again can be secured. The superheater, this is the superheater in the Benson boiler usually is an integral part of forced circulation system. So, therefore, no special starting arrangement for superheater is required. Now, superheater is again sometimes is a very you can say the useful attachment to the boiler to maximize the efficiency and because see sometimes if you are extracting the steam from boiler and if you are taking it externally to a superheater then you require some additional source of energy as well as there may be some you may experience the pressure drop, condensation, all these things may club together. So, this offers the in-house arrangement of superheated within the boiler system. So, that is why it is again a very beneficial aspect. Now, again these Benson boiler these can be started very quick because of the welded joint. There is no expansion joint, so you may not experience any kind of a leakage or any kind of other wear and tear problem and you can start very quickly. Now, these Benson boilers these can be operated most economically by varying temperature and pressure at partial loads and overloads. So, the desired temperature can also be maintained constant at any pressure. So, you may see that a lot of flexibility are attached to these boilers and you may vary, you may optimize the situation as per the requirement because the pressure and temperature you can easily maintain. Apart from this there is no you can say the expansion joints So, all these things you can see these are the favorable. Now, sometimes there you may experience that during the process there may be a sudden fall in the demand, and this sudden fall in demand, it creates the circulation problem due to the bubble formation in the natural circulation boiler. See, this type of a phenomena usually does not exist in Benson boiler. So, we may say that this particular phenomena never occurs in Benson boiler. Now, this feature of insensitiveness to load fluctuation, this makes it more suitable for grid power station, as it has better adaptive capacities to meet the sudden load fluctuation, and usually this is a very, you can say, sensitive phenomena if you are having the sudden load fluctuation, and sometimes major accidents may take place because of the overloading of these boilers. So, these type of things are very sensitive. Again, blowdown losses, they are very crucial for any kind of a boiler operation. So, these blowdown losses of Benson boiler are hardly 4% of natural circulation boiler of a similar type of a capacity. So, you see that this particular loss sometimes attributes to the major economic loss in any kind of a boiler. So, if it is on the lower side, then obviously the boiler operation would be more economical. See, the boiler safety is again very crucial and very important aspect, an important phenomena, because you see that the basic definition of boiler suggests that it is a pressure vessel. So, when we are dealing with the pressure vessel, that means there may be a chances or there may be chance of explosion hazard, and since it is a pressure vessel, so the explosion hazard sometimes make very severe, and if you go to the literature, there are various boiler explosive accidents, and it creates economical loss, also the human fatality. So, if the Benson boiler, if we talk about the Benson boiler, the explosion hazards are not all severe, as it consists only tubes of very small diameter and has a very little storage capacity compared to the drum type of a boiler. So, if they are having very less storage capacity, that means the chances of heat capacity would be on the lower side, and by this way the explosion hazard or consequences upon any kind of explosion, they are minimum. Now, during the start, the water is usually passed through the economizer, evaporator, superheater and back to the feed line via starting valve, so that whatever required energy or heat can be extracted and it can be maximized, it can have a maximized heat efficiency, etc. Now, during starting, the first circulating pump are started and then the burners are started to avoid any kind of overheating of the evaporator and superheater tubes. So, these evaporator and superheaters, they are posing a very smart phenomena of energy conservation. So, at the last of this particular lecture, you see that we had discussed about the Stoker type of a system. We discussed the system of the boiler classification with the two different type of boilers like Lamont boiler and Benson type of a boiler, and you see that the basic objective of these different type of a boiler study is to cater the need of your requirement. For the convenience, we have enlisted various references. You may go through all these references. Thank you very much.